Hello there. In this class we are going to be continuing our discussion on 1's complement and 2's complement. So the first thing that you need to know right here is that both of these, like the 1's complement and 2's complement, these are actually derived from a representation of a signed number, that is what we call sign magnitude number. In sign magnitude numbers, the leftmost bit is considered as the sign bit. If this bit is 1, we will consider that number as negative number, and if this bit is 0, we will say that this number is a positive number, and the rest of the bits would be considered as the magnitude bits. Like by combining them you will find out the actual number. Let's say this is 7, and by this 0 it means that this is a positive 7. So this approach is continued in 1's complement and 2's complement. If you guys still have any problem in sign magnitude numbers, you can just put that down in a comment. In a few days I will create a video on that too. Okay, so if you want to find out the 1's complement, so first of all let me revise one more thing, that why do we need these complements. Now if you have a computer and you want your computer to represent numbers, simply let's say I'm trying to make my computer represents natural numbers. In that case I won't be needing like these 1's complements and 2's complement like any other complement. But if I'm trying to deal with negative numbers, or I can say signed numbers, in that case I'm going to be needing these complements. Now the thing is that you will need complements whenever you want to represent negative numbers in the computer. So in that case we have got currently two options here. One is 1's complement and the other one is 2's complement. Now let's see the first one, 1's complement. This is pretty much simpler. This is the easiest it can be. This is the simple step of finding a 1's complement of any number. Simply convert that number into binary and then simply invert each bit of that number. If it has 10 zeros, just convert them into ones. If it has 0, if it has 2 ones, it convert them into 0. Simply invert every bit. But mostly this complement is not preferred by developers. Why? Because normally when you are performing any kind of arithmetic operation on these complemented numbers, you will find like left out carry problems, like the numbers will left a carry at the end, which is like quite difficult to manage. So one reason is that, and the other reason is that in 1's complement there are two representations of 0, which can be ambiguous in most situations. So for that purpose this number like complement is not mostly used. Mostly this 2's complement is used. Now how do you find the 2's complement of any number? Now to find out 2's complement of any number, you need to follow simply these two steps. First of all, you will find out the 1's complement of that number, which you already discussed here. How do we get that? And after that you can simply add 1 to that number, to this resultant number, and you will get your 2's complement. This is that much easy. So we are going to be discussing both of these by examples right now. One more thing about 2's complement is that this is mostly implemented in all the systems here, and this has also resolved the issue that we were having here. Both issues, like the 0 representation issue too, this one has only one representation for 0, and this has pretty much like reduced these problems, these left out carry problems too. Now I've written some things here. I don't know if you can get these or not at the beginning. Now if you have a number, let's say you have a register, of register with the size of 4 bits. In that case 4 bits are going to be representing how many numbers. You can find out that range by this formula. How? Let's say you have 4 bits, so you will simply like replace this n with your 4. 2 power 4 minus 1 minus 1, which will become 2 power 3. 2 power 3 is 8. 8 minus 1 is 7, which will become minus 7 to 2 power n minus 1. 2 power n minus 1 is 2 power 4 minus 1, which becomes minus 7 to 2 power 4 minus 1 is 2 power 3. 2 power 3 is 8. So it becomes like this. So these 4 bits will be able to represent numbers from minus 7 to plus 8. Like to find out a range like this, you can use this formula, and you can also use the same formula for, it's not the same formula, you will see some difference over here. You can use this formula if you are using 2's complement to find out the range between to find out a range of a specific register or any memory unit that you have. So this is what 2's complement and 1's complements are. Now let's see like how do you find out the 1's complement or 2's complements of any number. this is very simple. The first thing that will be given to you is the register size. Mostly it will be given in every question, that what is the available register size that you have, which you are using. So let's say in my example, to keep things simpler, I've written 5-bit of my register here. So if you want to find out the ones complement of 12, you can simply do what? You need to convert this into binary. So if I have 5-bit register, it means that I'm going to be having 5 slots here. If I write I think 8 comes here, I need to write 1 here, 0 0 0. I think this is the representation of 12. Now I have got the binary representation of 12, but I still need to represent it using ones complement. Now there is a this is a small tricky question. Now if I want to find out the ones complement here, what will I do? This is a positive number, so there is no need to find out okay. So coming back, 3 2 1. So now let's see this example here. I have got an example here. The first thing that you will see here is the register size. Most of the questions will have this part where they will tell you that what is the size of the register, what is the size of the memory unit that you are using. Currently my size is 5. It means that I have got 5 bits to arrange here, and the number that I need to find the complement of is 12. So I need to convert this number into binary first, which becomes almost like 1 1 0 0 0. So this is the binary of 12. Now what do I need to do? I've got the binary number, so simply I need to invert every bit in this number. So if I invert these bits, 0 will become 1, 0 will become 1, 1 will become 0, 0 and 1. So this is the binary representation of 12. This is the ones complement of 12 in a 5-bit register. So this is how you can find out ones complement of any number. Just like that, if you have another number, let's say this is the number, you want to find out the complement of this one, simply you can do what? Double 1 and replace all the ones with 0. Simply invert everything. So this is how you take ones complement of any number. Now what about 2's complement? If we have 12, we need to find out the 2's complement of this number in the same environment that we had in the previous example. What will we do? We will first of all convert this number into binary. Again, we have 5 slots here. It means 5 bits of memory here. So this will be the representation of 12. I have got this binary number here, 0 1 1 0 0. This is the binary representation of 12. Now to find out the complement, 2's complement of any number, first step was to do what? We need to take one's complement first. So I'll take one's complement of this, which will be double zeros will be represented with double ones and double 0 and 1. Now I have got the one's complement here. The second step is to add 1 to that number. Simply I need to do is to simply add 1 here. 1 plus 1 will be 0, 1 will be on the carry here, 1 plus 1 will be 0 again, 1 will come here, 1 plus 0 is 1, 0 and 1 will remain on their places. So this 1 0 1 double 0, this is the 2's complement of 12. So it is quite simpler too as compared to the one's complement. It's quite not simpler as compared to the one's complement, but this is mostly implemented in all the systems and this resolves many other issues. That is why we prefer this one. We are going to be focusing on this one. We will do some arithmetics like addition and subtraction using this specific complement in the next classes too. In the next class we are going to be discussing how do we add numbers using 2's complement. We will discuss 4 cases. There are going to be 4 cases of 2's complements addition. So that is why we will discuss all of these comprehensively in the next video. Thank you.